Starting this day off, we'll start with an hello session, hello Solidity session, sorry, which is a necessity these days, obviously. Pleased to welcome Yaron Velner, a blockchain researcher, PhD in computer science. So please give a warm hello to Yaron.
Okay, so good morning or almost afternoon, everyone. So yeah, I'm Yaron Velner, and I was asked to give introduction talk about Solidity. We'll have some hands-on demonstration on how to read a contract, compile a contract, test it a bit, maybe even deploy it if everything will actually work well. So yeah, so basically when learning new programming language, so it's mostly about the syntax, new capabilities, and everything. But actually Solidity and smart contract in general, so they are very much, so the programming language is very high level, but eventually, very quickly, you will have to know the details of the underlying so-called operation system or virtual machine. Obviously, in this talk, I will only give very brief background about this, but the bottom line is that maybe unlike things you read on the internet or stuff people told you, so yes, Solidity is nothing like JavaScript, it's much more low level, resembles a lot C, even assembly. But yeah, nevertheless, it's quite easy to start working with Solidity, but it is important, to learn all the pitfalls and architecture along the way. So this talk is mostly about the demonstration of Solidity, show you how contracts looks like, a basic overview on the toolchain. We'll try to run something together, but it is necessary for me to give at least some introduction on where smart contracts are actually executed, what is the running environment. This is stuff that is really important, even when you start to solve a problem on the blockchain or say that you want to work with blockchain, it's really important to at least understand what is going on, to even understand if blockchain is what you want to do. So obviously on each of these bullets, we can talk for days. We'll try to do stuff quickly here. So yeah, we'll explain very high level background on blockchain, transaction, smart contracts. Then we'll try to do the hands-on Solidity demonstration. And later today, I have another talk, which I discuss about bugs and hacks and the really fun stuff. So yeah, blockchain. So blockchain is basically some consensus mechanism, distributed consensus. Some are more distributed than others. And basically it started with Bitcoin. We were in Bitcoin, so roughly the only thing you want to get a consensus on is how much Bitcoin you hold on your balance. So, like if the analogy of that, like we all know banks, right? So I have an account in Bank Leumi, so Bank Leumi has all my account details, he has your account details. When you transfer money to each other, then they just change something on their servers. So now Bitcoin does it only in distributed manner and allow people to actually get a consensus without any central server on how much balance you have. So this is Bitcoin, and this is, so this is like the original blockchain. But then came Ethereum, and now almost everyone, and say, okay, other than the account balance, account can also have a code, and then account with code is basically a smart contract. It can also have storage, which again, it's the storage of the smart contract typically, and then nonce, and nonce doesn't really matter what it is for this talk. But the thing is that, okay, so smart contracts are simply accounts, only they have two more special property, which is they have code and they have storage or some kind of state. And then everything is run on the blockchain, and people all over the world, namely miners or validators, reach into consensus on what is actually the state of the contract and of the code. So we have accounts. Already in Bitcoin, right? The main thing that account can do is send transactions to each other. And again, if you go back to Bitcoin, so I just send, some kind of value, Bitcoin, from my address to your address, and that's it. Already, so in Bitcoin, actually, transactions are different, but even before Ethereum, some transaction had some data field on them, and you can just log it as some kind of comment. I don't know, something like maybe invoice that we did today, but it didn't have like real meaning. And other than that, something which is also very important, that transactions here, you have to pay eventually to include your transaction in the blockchain. So before Ethereum and smart contract in general, the data was just piece of info there. But then with Ethereum, also shortly before that, we had the master coin, which tried to do it on blockchain. So all of a sudden, we have input data, and recall that everyone has a consensus here, consensus on this input data. So now with smart contract, this input data will typically represent some function call. Okay, so we have now a transaction. If we send it to a simple account, typically it's to send ETH there or some kind of value. But if we send it to a smart contract, then typically the data is the information, is the function call to the smart contract. But this is all in kind of application level, right? What eventually the low-level smart contract see is just, this stream of information. And yeah, so smart contract have code and storage. So technically in a blockchain, there's no real distinction between an account and a contract, but from application point of view, a contract is an account with some code. So today we talk about Solidity, but of course what is eventually really there is some kind of assembly language, or this is not even assembly, this is EVM, which are low-level instructions to the virtual machine. Now, and this is very important, this code is executed only when someone sends a transaction to the smart contract, which means that at least naively, you cannot have a smart contract that will be executed, I don't know, tomorrow at 1 o'clock. Smart contract cannot initiate a transaction, is only responsive to other transactions. So whenever someone sends a transaction to this address that happens to contain a smart contract code, then it actually executes the instructions that are there. These instructions might change the value of some storage, and also it might send value Ether in this case to other contracts or to other addresses. Of course, it can also do nothing, which is less interesting, but definitely possible. So basically it is activated upon transactions or if other contracts call it. Therefore, also in turn, it can also invoke other contracts. But really the important thing here to understand is, okay, so first of all, it's very reactive, only responsive and respond to transactions, but also it has no kind of existence outside the blockchain. It cannot read anything, I don't know, it cannot search on Google, it cannot read data feeds from Bloomberg. You might have some other protocols in the middle that will commit on relaying the real data from Bloomberg and everything, but smart contracts only live on the blockchain, can only read from the blockchain, can only write on the blockchain. Then whether their operation have some monetary value, this is all kind of social agreement, it's not really on the blockchain, etc. Okay, so everything is on the blockchain. If you want to do something that has external effects, of course, either don't use smart contracts, or typically you will just have to introduce some other layers of some kind of social consensus around it. So now we are ready to dive in a bit for Solidity. And let's hope everything will work. So actually, I know for those of you who actually have a laptop here, so if you didn't already at home, let's run it. So we will have it installed later. So just install a hard hat. So npm install hard hat. And yeah, let's hope it will actually work. Yeah, okay, so now let's dive into the code. Yeah, also in the meanwhile, while I'm explaining, so if you want to run the demo, so go to this URL and copy the code. So tiny URL, and then these letters. Let me know if you want me to increase the size of the font. So for those of you who don't work much with GitHub, it will be easiest to just hit on the row button and then just copy paste everything. Yeah, okay, so this is a smart contract, Solidity smart contract. By the way, Solidity is not the only programming language for smart contracts. Viper is another one which has some popularity. So this is the actual code. Later we'll take a brief look at the compiler, which actually compiles it to the ugly instruction set you said before. So yeah, so Solidity has a bunch of some syntax stuff that the compiler enforces, because actually when you write code, so one thing is to actually, the code has to be correct and everything. But here in this ecosystem, you also want others to know what the code does. Because eventually on the blockchain, you will not see this code. You will see some ugly instruction sets. So you want to actually let people know how to verify that the code that you are claiming that they use is the actual code. So you have like stuff like a Pragma Solidity, which sometimes can enforce a compiler version, or at least a range of compiler version. You need to declare the license of the code, which again, not really kind of core part of the language, but if you start writing, this is the first thing that the compiler shout. But yeah, so if you ignore the first 4 lines, so yeah, so smart contract is, first of all, so it's a contract. So if in JavaScript, C++, whatever, you have classes, here kind of the core object is a contract, where again, so contract is a code, code with a storage that is deployed in some specific account on the blockchain. Of course, when you want to write code, so first of all, you need to kind of understand or decide what you want what do you want the code to do. So here we implement very naive voting system just to demonstrate, like the Solidity syntax and layout. So in this smart contract, we will have storage, which will actually keep the votes. Okay, so we have a counter for the no votes and the yes votes, and we also have some storage that say, okay, how many votes are actually needed for a vote to pass. So this is something. So this is a storage where potentially every execution of the smart contract will change some of the storage, but then this storage is persistent, remains for the next execution, basically live in the blockchain forever, basically. This is also why storage operations are very expensive. So if you look at so first of all, we have the kind of data types, right? So uint is unsigned integers, And basically, in Solidity, you only have very low-level primitive data types, so integers, booleans, and addresses, where addresses are basically the account identifiers. You also have structures and some very basic memory or strings, but very basic there. So when we declare a storage variable, we can say whether we want it to be public or private. Where basically, so it means two things. If the first thing means that whether other smart contract can have access to the storage. Also, it is mostly used is for actually kind of web applications so it gives you a convenient interface to read it. Or it can be private, where private is also the default. But here it's very important to understand that private variables are not private at all. Everyone see all you do in the blockchain. If you run a local Ethereum node, you can easily query it, even with Web3 calls. Doesn't really matter what it means, but there's no privacy at all in the blockchain. So, but like a private storage variable simply means that no other smart contract can read it. But of course, the entire world can easily read it. And from application point of view, so there are actually two justifications for that. So the one, for one thing, it saves some code in the contract, and every code here eventually translates to some gas costs. And then another one, which to my knowledge was never used, but it's like the main motivation here, is that potentially a smart contract, might want to actually charge money for people to read it. So you have, for example, price oracles that might let, only whitelisted paying accounts read it from the blockchain. So that was the main motivation. These days, this use case is even considered a bit not realistic because there are some workarounds on how to actually read private variables. But yeah, okay, anyway, this is a bit of advanced topic. So we have storage. Then we can define structures, which is very similar to C structures. Just list of variables. And then like the only high-level feature that Solidity actually have is this mapping, which is kind of a dictionary, the dictionary from Python or JavaScript or whatever. So they just map, in this case, address to a user, where in our application, in our smart contract, address is basically an account, and the user is the information on this account. And as in JavaScript and Python, so it's relatively quick. I wouldn't say cheap because storage reading is expensive, but so it's relatively quick to access an address here. So this is the storage layout. Then you have a constructor, and of course a constructor is code that will be executed only when deploying the smart contract. Yeah, so now maybe let's dive into the actual application that we try to write. So we have a yes, no, and a no vote. We have quorum, which, for example, could mean that only if 50 people participate in the vote, only then the vote is valid. So here in the constructor, we just set the quorum according to the input parameter. And then later, this will never be changed. Let's scroll a bit down. Okay, and now, so a smart contract has functions. And every function, of course, has the inputs that it gets. Potentially can return value. But also every function can be either external or internal, where external, and you also see public, so external and public functions can be called also by other smart contracts. Also, they can be easily called from a web application, where internal functions can only be called within this smart contract. So let's implement a vote function. So in a vote function, we just want to say if user voted yes or no. So we ask for an input to be exactly that, yes or no. Okay, and now some additional attributes that Solidity give us. So like in a normal vote function, you would also want to say who is the guy who is voting, right? Who triggered this transaction. So we have the message sender attribute here, which basically, okay, so message sender is the address that actually triggered this transaction, where this triggering can be either user who made a transaction or a smart contract that actually called it. So the first thing, we go to the user's mapping and we check that the user didn't vote in the past, okay? And here this require function, so it's like assert, and if it's, okay, if the assertion is false, it's reverting, okay? So what is actually, so what reverting mean? Reverts mean that the operation stops, but also all the changes that were done in the storage during this execution are also being reverted. So eventually it promised that there's no consequences on the state of the blockchain, other than the actual gas that was paid to execute it. So even if transaction reverts, someone has to pay for gas, otherwise it's some kind of an attack vector. So yeah, also, again, as you deep in and maybe write more complex applications, so to be more precise, it reverts this execution. There might be more high-level execution, which is not reverted, but this is like more advanced part. So we first check that user didn't vote in the past. Now we update the user status that, yeah, okay, he did vote. He voted either yes or no. And then we call the internal update vote function. And this function here is mostly to illustrate why internal functions are very important. Obviously, if you would forget, declaring it as internal, then anyone could have come and just call this function and change the voting status. So it's very important for it to be internal, and it guarantees that it can only be executed from within this code. Also, so in my later talk in the afternoon, I talk about case where someone actually forgot to make it internal, and over $100 million of funds got lost because of it. So yeah, so it's very important to know, if it's an internal or not. So yeah, so that's the voting functionality. Now if you look at the get results function, so here we see a new thing. So first of all, it is classified as public and not external. But if you are at an early stage, so just assume that public is external. There are some gas consequences there, but too complicated to explain. But yeah, so public and external is roughly the same, but the new thing we see here is this view, which means that this function doesn't change the state of the blockchain or of the smart contract. So yeah, so view modifier means that you cannot change the state. Actually, not only of the smart contract, if we have like additional calls to other smart contracts, so view function cannot change them. So, as a user, you should much more easily call this view function rather than non-view function, because view function can never steal your money or whatever, because basically it cannot do anything. So yeah, so we have a view function. Now we have a return value, because actually if a function doesn't do anything, it's kind of useless if it doesn't return anything as well. So here you can return, so this is similar to JavaScript probably. You can return multiple values, even array of values. So yeah, here we want to say whether there was a yes majority and whether the quorum was actually met. So yeah, so we check if there are more yes than no votes. Here we calculate the total votes, but this is also to demonstrate that, okay, this variable is not part of the storage. It will not have a persistent state. And after this function finish the execution, right, it will reset. So this is a non-storage variable. Technically, it is stored on the stack. You also have some memory variables at this stage. For you, it's probably the same. And then we set the last return value that just say whether the quorum was met. So this is the basic voting mechanism. And now to demonstrate, like further features, so we implement another feature, which is paid vote, which conceptually only people who pay, or people who pay can vote regardless to whether they voted in the past. Of course, it might not make sense, but this is just for a demonstration. So here we see, okay, so all of a sudden a new syntax, which is the event. So event is not a function call. It's sort of, so formally it is log. You can, I don't know, maybe envision it as some kind of print into the screen. Of course, in the blockchain environment, you don't print anything to the screen. All you can change is the blockchain state. But these events have some effect on the blockchain state, but relatively cheap one in terms of gas, and later applications, web applications can easily read them, but they don't have any effect that any other smart contracts can read. So here we just want to have some kind of print or say to the world that, okay, now someone who actually paid vote. It's not that without it we could hide it, okay? Even without the event, people could detect it. But basically it makes the life of web developers much easier because you have now relatively simple interface to read these events. Fine, so in the paid vote, so again, we have a yes or no vote. And now if before, if before we looked at the message sender, who is the guy who actually sent the transaction, now we see another attribute, which is message value. And message value is actually how much ether, okay, the user sent with this transaction. Okay, this is why also, so here we see the function is external because it can be called from the outside, but also the payable modifier, where payable modifier basically means that, yeah, okay, so you can send, you can call this function and also send is along with it. And this payable modifier was added because, again, so also here, at least hundreds of thousands got lost because people send is to places they shouldn't have sent. And lost here is just stuck forever. No one even made profit out of it. So now Solidity can actually force that, if you call to a regular vote, you should never send is with it, otherwise it will revert. But if you want to send is with it, then you have to have the payable modifier, and then the message value actually says how much is was sent. Okay, so here we require a payment of 1 ether, and when this is executed, the ether already resides in the smart contract. Of course, in this smart contract, it will just get stuck. We don't do anything with it. But yeah, but again, we have like sort of validation that user actually send 1 ether, and if he send it, then yeah, we update the vote according to what he inputted, regardless if he voted before or not. So yeah, so that's a simple smart contract. And yeah, maybe last chance to copy it if you didn't already. And yes, so now, okay, so we have a smart contract. So now in the real world, we will probably test it first and then deploy it. But we are in crypto and in this conference, so maybe let's first deploy it, then see how to test it. So yeah, so like in one of the links to this call, to this talk, so I provided this link to remixethereum.org, which is online compiler. Personally, I don't use it much, and if you write a lot of code, you probably won't use it either, but just to start with, so you can write code here, you know, you can compile it. You even have some kind of debugging and running environment, which again, personally, I never use, but as a quick start, if you have like a simple contract, so yeah, it might be useful to you guys. So that's remix.ethereum.org. And yes, so, you know, so we write the smart contract here, we compile it, you can compile it with different compiler versions, and then we deploy it probably, yeah, okay, here. Yeah, okay, so typically, right, when you start, so you don't, especially on Ethereum, so these days, actually in the last week, the gas is cheap again, but still it will cost you probably like maybe $20, $30 to deploy. In bad days, could be even $100, $200 to deploy. So of course, if you want to develop first maybe some web application around it, you will deploy it on testnet, where testnet is kind of free money. Unfortunately, I don't know if you guys follow, there was recent merge in Ethereum, testnets also got merged. I lost all my testnet money, but luckily today you actually have cheap networks, so I will deploy it on Polygon. But yes, so you write the code, you need to connect your MetaMask, you need to have some kind of either money or testnet money beforehand, otherwise you cannot do anything. If you want to actually deploy it later in the testing environment, you can see that you can actually run it locally, which is typically fine. Yeah, okay, so before calling deploy, recall that we have a constructor parameter, namely the needed quorum. So let's put the, I don't know, 13. Click deploy. Yeah. Also, kind of heads up, these things typically don't work, or you know, at least. Yeah, I mean, obviously it works because I tried this scenario before. But yeah, in general, the tool stack is very hard to work with, but it's getting better all the time. So yeah, so now I have a transaction. This is my actual, so in this case, Polygon wallet. I confirm the transaction. Yeah, okay, of course it failed. Okay, because the transaction was underpriced. Okay, so I guess as an early stage developer, it's kind of hard to know what to do. But eventually you will learn. So I will just manually edit the gas fees. So yeah, so Polygon is very cheap. Of course, when you start home, so I don't know, like experimenting is the best thing. There are maybe some forums that will help you, with some questions. But yeah, you see, okay, so eventually here, so this is live broadcast transaction was actually included in the blockchain. This is a block explorer, also important tool. So this is Polygon, but on Ethereum, Etherscan is the one you want to use. If we refresh enough times, yeah, okay, so this is the actual transaction. You see, okay, so this is how a contract looks. So you see it was deployed 29 seconds ago, so this is the actual contract. Of course, this is not the proof that this is the actual contract, but if you want a proof, you should go to the code tab. Also here, the code it's not something automatic. It's just something I uploaded yesterday. So now this tool knows how to recognize this code. But of course, every smart contract you deploy you'll have to manually add it there. And then, of course, the proof that this is really what you want is not even here, because this is just some kind of centralized, so polyscan.com, which show you something that might be the code, but there are more advanced tools to actually run it from your local computer and verify that, okay, this is the code. So now, okay, so we deploy the contract, we have an account, so this is the address of the account, we have code, and yeah, so the contract is there. Let's even try to use the contract. And this is something I never tried at home, and this is also not very tested, so let's see if it is actually working. So yeah, of course, giving an input, yes, no, what can be more easy, but of course, you never know if it's one, true, or yes, but yeah, it seems to work. So yeah, you can interact with the smart contract. Of course, in a bigger application, you will have your own web interface, which will be prettier. So you see, I call this function. Yeah, okay, so it's not really support, it's yes, no, but it kind of remembers old ones. Yeah, transaction was completed. So just final step to prove you that something really happened. So we can also read from the contract. Again, only the functions we already implemented. So yeah, we have the get result function. Let's query it. So yeah, I don't see what is there. Yeah, okay, so quorum was not reached because only one person voted. But yeah, but the majority so far is yes. Yeah, okay, so we deployed the contract. Now let's test it. So yeah, so previously, those of you who did, so we installed Hardhat. And to get more resources on Hardhat, go to hardhat.org. Yeah, let's see what is the outline. Okay. So to start, we do Hardhat init. We start a new project. At this point, we didn't even write the code, right? So in this demo, I wrote the code beforehand. But yeah, okay. But typically, you will start this Hardhat init before ever writing the code. So yeah, there can be JavaScript or TypeScript. We'll just click yes on everything. Yeah, okay. When you do it yourself, you probably want to read what is there. No, and particularly if you are more of a TypeScript fans rather than JavaScript fans. Right now, most of the testing environments are either JavaScript or TypeScript. There is one which is now gaining popularity, which from what I heard is on Rust. So if you like Rust, you can also do that. Yeah, other popular testing environments, so Hardhat, you have Truffle, which used to be very popular, now is less popular, and the latest one, which is cool but very new, is called Foundry. So yeah, installation was completed. So I hope you see the layout because I don't. Yeah, okay, so we have a test folder and a contract folder. So yeah, so let's start with the contract folder. And again, of course, at home, you will do it with a decent code editor. But the goal now is just to go to the contract folder and override the code with the sample we had. Yeah, okay. So I prepared it in advance. Yeah, okay. Yeah, so that's the code. And now, yeah, so now you can also compile the code. So hardhat compile. Yeah, okay, compilation was successful. Yeah, with even one file. Yeah, now if you go to the test folder, so yeah, you see tests there. So let's also override the test. Yeah. Yeah, okay, so actually here, yeah, so in the slides I have a link to the test, and we don't have a lot of time, so just trust me on this one. Okay, if you are quick, then again, tiny URL and these things here. So copy the test. Yeah, okay, maybe just quickly go over the test. So it's based on the Mocha testing environment, which, to be honest, I don't know much about. But the point is that you can actually call functions, you can deploy contracts, and you can read from them. I think there's a call later today about how to do actual testing. So he will probably know. No, so I know a lot about tests, but not about kind of the theory around it. And yeah, now just to run the test. So hard at test, and okay, we're already in the test. 1 second. Yeah. Test. Yeah, okay, so you see, so, okay, if you dive more at home, so intentionally one test pass, one fail, and yeah, okay, if you were able to copy it, so an exercise is to actually try to revive the test. So yeah, so that's the running environment. Yeah, okay, deployment, I actually showed you, deployment example. So yeah, this is the basic. You can now deploy code and run it, but of course there are a lot of advanced topics which you will immediately hit if you start. So things you definitely want to learn is gas consequences. This is, you should know already from day one. Especially there are stuff you're not allowed to do, like unbounded loops, storage operations are expensive. Then the next step, which is more advanced, but again, to be a good programmer, you will eventually have to learn it, and you will actually see it, in many contracts, is kind of special crypto primitives, such as hash functions and digital signatures. And then, of course, you should always spend a lot of time reading game theoretic attacks, security models, because yeah, there are a lot of stuff there. And I also welcome you to my 4 p.m. talk, where I can share some horror stories there. So yeah, so thank you very much. If you want to learn more Solidity and you're not even completely, so this is very detailed reference. It's also in the website links. So go to soliditylang.org or just Google Solidity, read the docs. It's relatively nice place. Also with advanced explanations on some on best practice on security, stuff like this. Yeah, you can contact me on Twitter. And yeah, thank you very much.